Ph261, Chapter 6, homework problem number 1. It says a worker pushes horizontally on a 45 kilogram crate with a force magnitude of 101 newtons. The coefficient of static friction between the crate and the floor is 0.45. So we can start here by just illustrating what exactly is going on. So there is a box here, and it has a force acting on it of 101 newtons, but just to illustrate, that's the force. Then it's going to have the force of friction. It's going to have the normal force, and of course, mass times gravity. So from here, we can actually list what we have. We have mass is 45 kilograms. We have the force applied, which is 101 newtons. And we have the friction coefficient, which is 0.45. And from here we can just note a few things, that the force of friction is going to be equal to the frictional force times the normal force. And seeing this diagram here, we know that the normal force is equal to negative mg. So with this, it asks what is the frictional force on the crate from the floor. And all this would be is this is the frictional force here, right? I guess this would be the wrong thing. This is, I don't know, a frictional force, I don't know, FF. And it's just going to be minus FA. So the frictional force is going to be negative FA, or actually, because the box is moving this way, it would be the opposite of that. It would be the negative of frictional force is FA. So this would just be 101 newtons, and then it asks what is the maximum magnitude, Fs max, of the static frictional force under the circumstances. Now this is the Fk that we were looking for. And what this is if we know that Fn is mg, then we know that Fk is going to be 45 times 0.45. And that is going to be, because that's mg, it's going to be 45 times 0.45. Let's see. Oh, that's mass. Sorry. Mg is mass times gravity times, times 9.8 times 0.45. Here we go. So that is going to be 198.45. Okay. It asks, does the crate move? So if this is the force that is applied, and this is the static force, or the force where it won't move, then we can see here that 198 is greater than 101. So the force applied is less than the force needed to move it. So the answer here would actually be no. And suppose that a second worker is pulling upward on the crate to help out. What is the least vertical pull that would allow the worker 101 newtons force to move the crate? So to move the crate, this is going to be 101 is going to equal, which is going to be the negative mg plus the force times the friction coefficient, because we're trying to find now this Fk is going to be the force applied, because that would be the least amount. That would be the force needed to move the crate. So Fk has to equal 101. And from here, we divide 101 by mu k, which would be 101 divided by 0.45. It's going to be 224.4. And if we take that now, and we subtract mass times gravity, minus mg, the answer is going to be 216.5. And then it asks if instead a second worker pushes horizontally. Now, this is going to be 198 minus 101. Because this is the force we have to overcome. This is the force already added. So the force needed to overcome this is going to be the, I don't know what the word is, difference maybe would be the difference here. So that is just going to be, let's see. 1. Yes, this is going to be the 97.5. These are not the exact. If you use the exact numbers, of course, you would get the 0.5. This is kind of like the estimate, not 198, 101. So there it is. That is the answers for this whole problem. Those are the answers.